Alright, so we're going to be going over how to find limits graphically. So these are some points you want to note concerning finding limits graphically. If you're finding a directional limit, for example, the limit as x approaches a. If the limit as x approaches a, let's say from the right of f of x, if it's going to a point, the point can be open or closed. So it can be a removable discontinuity or a defined point. If the limit is approaching a point, the answer is going to be your y coordinate. The y coordinate of the point that you're approaching. It doesn't matter if the point is open or closed. That doesn't matter. The whole concept of the limit is you're approaching the point. You do not have to get to the point. Alright? So if you're approaching the point, whether open or closed, your limit, your directional limit, is going to be the y coordinate of the point that you're approaching. The next case is if you're approaching an asymptote. Okay? So the limit, let's say you have a directional limit. It could be from the left or from the right of a function, and what you're approaching is an asymptote, a vertical asymptote. Let's be specific here. If you're approaching a vertical asymptote, then your limit is either going to be plus infinity if you're heading upwards, or negative infinity if you're heading downwards. When you're approaching a vertical asymptote, you're either going to be heading up to infinity or heading down towards negative infinity. So the direction that you're heading will tell you what the value of that limit is. Okay? And then the last thing that you want to keep in mind is the value of a double-sided limit if the left and right hand limits are different. So if the limit as x approaches a from the left is not equal to the limit as x approaches a from the right, then in this case the limit does not exist, because you're not approaching the same exact value. In order for the double-sided limit to exist, let me correct this. Yeah, can we write this as then the double-sided limit as x approaches a does not exist. Now, one thing you want to note is the notation for double-sided limit. Notice that a does not have any direction specified, left or right. That basically means you're going from both sides. Alright? So if you have a double-sided limit where the left and the right are different, then that double-sided limit does not exist. So let's assume that this graph is a graph of y equals f of x. And then the task is to evaluate the following limits. Alright, evaluate the following. It doesn't even have to be limits. Evaluate the following. Number 1, what is the limit as x approaches negative 5 from the left of this function? So we are approaching negative 5. The direction is from the left. So you look at where at -5 right here. What do we have at -5? At -5, the intersection between -5 and the graph is a point. The point has a removable discontinuity. Whenever you're finding the graphical limit and you're approaching a point, the limit is the what? So when you're finding a graphical limit and you're approaching a point, if you look here, this is a point that's undefined. The limit is the y-coordinate of the points that you're approaching. So since you're coming from the left-hand side and you're approaching this undefined point right here, the limit is the y-coordinate. So you simply trace it to your y-axis, and that, ladies and gentlemen, is your answer. The limit as x approaches -5 from the left is equal to +1, the y-coordinate of the point that you are approaching. Alright, how about we approach that same point from a different direction? What is the limit as x approaches -5 from the right of f of x? If you're approaching 5 from the right, which is from this direction, what you find out is that you're approaching the same point. Okay? So let's say this is -5 here. This is approaching -5 from the right, and this means approaching -5 from the left. Okay? But when we're approaching -5 from the right, we are approaching the same point, the same undefined point here, with a removable discontinuity. Actually, the point is defined, but you have a removable discontinuity. It's defined somewhere other than the line. So if you're approaching a point for a limit, how do you find the limit? So the limit here is also going to be the y-coordinate. Since it's approaching the same point as before, we're going to be approaching the same y-coordinate. So your right-hand limit is going to be +1 also. Alright, and then lastly, our double-sided limit is going to be limit as x approaches -5. No sign indicates left and right. Now, since the left and the right-hand limit are the same, the double-sided limit is going to be equal to the value of the left and right limits. Okay? So what this double-sided limit is telling you is that when you approach this x value from the left and right, you are approaching the same point. Okay?